Okay, what we just verified, what we just saw of the first two examples was that when we graph, we can find an answer to these problems, right? So if we get a problem that looks like this, we have the ability to graph to get an answer. Okay, what I want you to see is what we normally see is this first scenario. We perform elimination or substitution as we normally do. I want to get rid of x, so you do whatever multiplication necessary to get rid of x. You do what you normally do. If the system is a consistent independent system, it means the other variable is still there. So, in other words, if we get what we just looked at, we get two lines they cross at some point, that's normal. All right? That is this one right here. Okay? In other words, you perform elimination or substitution, and let's say you eliminate x. Y sticks around for the end of the problem. Okay, that's a normal problem. Or if you eliminate y and x sticks around for the rest of the problem, it's a normal problem. So there's an answer xy, which represents the point of intersection of the two lines that would be created by the two equations that we're looking at. The second scenario, this one here. You perform elimination or substitution as you normally do. In the process of eliminating x, y also eliminates. You didn't mean for that to happen, but it just happened. You did whatever is necessary to make x go away, and all of a sudden y also goes away. You got 2x and negative 2x, you got 3y and negative 3y. All of a sudden they're both canceled. But the leftover statement is going to be a true statement. 0 equals 0, 5 equals 5, 9 equals 9, something along those lines. When that happens, what you're looking at is a line, and then the other line, let's go in a different color here, let's go maybe green. Then you have the other line is exactly the same line. Two equations make the exact same line is a consistent equation but dependent. So consistent independent is one we normally do. Consistent dependent, one line sits on top of another line. The third scenario is that you do elimination or substitution as you normally do. The other variable cancels also. So I want to get rid of x, do everything necessary to get rid of x, but y goes away also. We're left with a false statement. 16 equals 5. Negative 10 equals 7. 0 equals 0.2. Something weird like that. All right. What we're looking at then is a pair of parallel lines. There's line 1 and line 2. Parallel lines. There is no point of intersection in that situation. So with the consistent dependent line on top of the line, all real numbers, for parallel lines, empty set. Whenever it says solve one of these problems, they're looking for a point of intersection. One point of intersection, infinity points of intersection, no points of intersection. And again, the official wording that we want to use for these is consistent and independent for the normal, consistent and dependent for the line on top of the line, and inconsistent for the parallel lines. All right? Let's give it a shot. Determine whether the following set of equations have a common solution. Again, I want to use the words consistent, independent, consistent, dependent, or inconsistent when we get asked this question. So, looking at its setup, is it easier to do elimination or substitution?
Substitution.
Substitution is easier. Y equals everything else here, so I can put that x plus 2 in place of that y there. So if I do that, y becomes x plus 2. It equals x minus 1. So you do substitution like you normally do. Okay? Nothing weird about that. Y got taken out, x plus 2 got put in, because that's what y equals. Once you do substitution, then you go ahead and continue working substitution like you normally do, which is to solve for x, right? So I'm going to move this x over to the left. I'm going to move this 2 over to the right. X minus x is 0. So notice in the process of trying to solve for x, x disappeared also. The right-hand side, negative 1 minus 2 makes negative 3, and we're left with a false statement. So again, that happens sometimes. I did substitution. I did it legally. I didn't break any laws when I did it. I went ahead and tried to solve for x. In the process of trying to solve for x, x just disappeared completely from the face of the problem. And we're left with 0 equals negative 3, a false statement. So that means the answer to the problem is empty set, and the type of system it is inconsistent. That's what I'm looking for on these problems. When it asks for, is there a common solution, I want you to tell me what type it is, consistent independent, consistent dependent, or inconsistent, and then tell me what the answer is. For inconsistent, it's going to be empty set. A set of empty set brackets is another way to write empty set if you wish. I prefer the 0 with a slash, so it's a lot easier to write, but if you really want to, you can do the empty set, for instance, like that.